There's a question from a CCEA A2 Pure paper. This one's from June 2023. We're taking a look then at question 5. So a couple of parts to this, partial fractions and a wee bit of integration. So let's see what we have. Express f of x equals 25x upon these in partial fractions. So the way we look at partial fractions is we always look and see, first of all, is the degree of the numerator higher or the same as the degree of the denominator. Obviously it's much lower, so we don't need to do a long division first of all, and then we look at what type it is. So this one is a repeated factor. You can see here this one's repeated, so we need to set it up then as follows. So I already have this one started. So we're f of x a over x minus 2 plus b over x plus 3 plus c over x plus 3 all squared. To find our common denominator, we need to multiply top and bottom of this one then by x plus 3 squared. That's what we have here, and I'll jump in from there then. So the b then needs to be then upon x minus 2 x plus 3 all over x minus 2 x plus 3 squared, and then c upon x minus 2 all over minus 2 x plus 3 all squared. We're going to join that together then and equate it to the top line. So my 25x then is going to equal the numerator along here. So let's set that up. So we're going to have 25x equals a upon x plus 3 squared plus b upon x minus 2 x plus 3 plus c upon x minus 2. I'm going to let x equal to minus 3. If x is minus 3, then I'll get minus 75 here. It makes this disappear and this disappear, and that gives me then minus 5c. So that gives me then c is 15. I'm going to let x equal to 2. So that'll make this term disappear and this term disappear, and that means 50, because that's obviously 25 times 2. Then 2 plus 3 is 5. That gives me then 25a. So that gives me a then is 2. To work out the c, you can do a couple of different things. You can sub in, for example, x equals 1 and sub in your a and c to work out the b, but I'm just going to equate coefficients. So if I equate coefficients of x squared, so here then we're going to have 0. There's going to be a 1x squared there, so that's going to be our a, and there's going to be a 1x squared there, so that's going to be our b, and that gives us then a value of b equals minus 2. So I'm there, I've got my 3 values, 1, 2 and 3, so my function then becomes a, which is 2 over x minus 2 minus 2, sorry you can't see that, over x plus 3, and then plus 15 all over x plus 3 all squared. Look then at part 2, hence find the exact area of f of x. So obviously we've rewritten it then as partial fractions, so effectively what we're trying to find then is the integral between 1 and 0 of the answer that I've just written out. So it's 2 x minus 2 minus 2 upon x plus 3 plus 15 over x plus 3 all squared dx. So this here is going to be an ln function, this one's going to be an ln function, and then this I'm going to bring this up and integrate it. So it's going to be the integral between 1 and 0 of 2 over x minus 2 minus 2 over x plus 3 plus 15 over x plus 3 all to the power of minus 2 dx, and then go ahead now and integrate. So that 2 is going to have to jump out to the front, and then it's a straight ln, so it's going to be 2 ln x minus 2 minus 2 ln x plus 3. And then I need to think about this one here. So effectively, whenever I differentiate that, it's just a 1 coming out of that, so it doesn't affect that too much. So it's going to be the minus coming out of the front end. So minus 15 upon x plus 3 to the minus 1. Effectively, I did like a backwards differentiation. So how would I differentiate that? I would take away 1 from the power, which means it's minus 2, multiplied by the old power, so that minus 15 times the minus 1 gives me the 15, and times then by the bracket differentiating, which is just going to be our 1. So we have that from there. Starting to substitute things in, so we have a mess here, but we'll sort it slowly but surely. So we're going to substitute in the 1 there, so that's 1 minus 2, so it's going to be 2 ln of minus 1, so that's not going to come to much. Here, minus 2 ln 4, and then substituting the 1 into here, so 1 plus 3 gives me 4. 4 to the minus 1 is of course just 1 over 4, so that's going to be then minus 15 over 4. If I substitute in 0, I get 2 ln minus 2 minus 2 ln 3, and substituting in 0, 3 to the minus 1, so that then is just going to give me then minus 5. So 2 ln 1 is going to be nothing, so I have minus 2 ln 4 minus 15 over 4, minus 2 ln 2 minus 2 ln 3. That's going to be a plus there, and then that's going to be a plus 5. So let's take away look. A couple of different ways of attacking this, but I'm going to do it this way. I'm going to take this term here and this term here, so that would be 20 over 4, take away 15 over 4, so that gives me a 5 over 4 there. And then these terms here are all 2, so I'm going to take a 2 out the front, so it's going to be then plus 2 upon ln 3 minus ln 2 plus ln 4. You need to look at that a wee bit there, both negatives, so they're in there, and we have that. So how do our laws of logs work? We do the 2 times the 4 there to get the 8, and then that's going to be 3 over 8, and that gets me then what's hopefully the correct final answer. So it's 2 ln 3 over 8.